Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Flamingo Croquet by Katie Splendor. And here are the rules. This is basically a take on Alice in Wonderland, but I believe the person was named Ollie in Wonderland. But these are essentially references to, I believe, Alice in Wonderland. Anyways, let's get to the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We also have wickets, where digits on a blue wicket line must not be between or equal to the digits in the diamonds at the line ends, and the diamond digits must be at least 4 apart from each other. I believe these are called lockout lines, is another way of putting it. Obviously, this is Alice in Wonderland themed, so the wickets are the wickets that you hit the balls through. This is basically croquet. But these are lockout lines, essentially. And the diamond digits have to be at least 4 apart from each other. So, for example, if this were 3, this would have to be 7, 8, or 9 to be 4 apart from that. Because those are the only digits which are 4 or more away from 3. And then the digits on the line cannot be the same as the digits on the diamonds of the line. And they cannot be in between the digits on the line. So this actually can't be 3 and 9 because then the digits here would not, you cannot have 3 digits here that are not between 3 and 9 or are not 3 or 9 themselves, right? We only have 1 and 2. But if you did have 3 and 8 here, you could have 1, 2, and 9 here, which would satisfy this lockout line or these wickets. And we actually have a drawing too, I guess, of the wickets. And yeah, this is a drawing. So these are wickets where you hit the balls between, and we have balls actually between every wicket, which is interesting. And then you have the flamingo, yeah, the hedgehog balls, the flamingo mallets, and then the mallet handles. And then we have ratio hazards and XV hazards. Interesting. Okay. So we have hedgehog balls, where digits on a gray hedgehog ball must be odd. So these are just odd even circles, and these digits must be odd here. So for example, if all of these digits are odd. If we had 1, 3, and 9 here, this would have to be 5 or 7 to make sure that these digits are odd. So that is the hedgehog balls. We have flamingo mallets, which are otherwise known as Renban lines in normal Sudoku, where digits on a purple flamingo mallet line must form a consecutive set in some order. And they do not have repeats. So, for example, they're all 5 in length. So we could have something like, say, not 2 there, then let's say 3, 6, 5, 2, 4. This would be a valid flamingo mallet or Renban line because the digits on it form a consecutive set without repeats. 2, 3, 4, 5, and 6, right, are all form consecutive set. What you could not have, though, is something like 1 here, because 1, 3, 4, 5, 6 does not form a consecutive set, nor does 8. And you can't have repeats on the line either, because, I don't know. I would consider this a consecutive set, but it depends on how you define set, right? Do you count the 3 twice as a set? Anyways, you can't have repeats on these flamingo mallets, though, so keep that in mind. We have mallet handles, where neighboring digits on a hollow orange mallet handle must differ in value by at least 4. And I call these uh, mallet handles whisper 4 lines. Other people usually call it Dutch whisper lines, but a, a setter came up with the naming convention of whisper 5 and whisper 4 lines, and I thought it made a lot of sense because you can easily extend that to other types of whisper lines. And for example, if this were a 3, this would have to be 7, 8, or 9 to be 4 or more away from 3. And that's how mallet handles work. We also have ratio hazards, where digits separated by a black dot must have a ratio of 2 to 1. There is no negative constraint. And these are otherwise known as black Kropke dots. So, for example, if this were an 8 here, this would have to be a 4 here to be in a 1 to 2 ratio between them. And that's an example of how the ratio hazards work. We also have the XV hazards. It's kind of weird to have a hazard in between of a wicket, but anyways. We have XV hazards, where digits separated by V sum to 10. Sorry, digits separated by an X sum to 10, and digits separated by a V sum to 5, and there is no negative constraint. So, for example, if this were, say, a 3 here, this would have to be 2, because these two digits must add up to 5 because of the V between them. And if we had, say, a 3 here, this would have to be 7, because these two digits must add up to 10, because there's an X between them. And these are otherwise known as just XV clues or rule set. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get it started. Let's learn how to Sudoku. Okay, the first thing I spy is that these 4 digits are in a 1 to 2 ratio with each other. Well, to have 4 unique digits be in 1 to 2 ratio with each other, it has to be 1, 2, 4, and 8. That's the only set of 4 unique digits which can be in a 1 to 2 ratio all in a line. So we know the middle digits have to be 2 or 4, and the outer digits must be 1 or 8. Well, this 1 or 8 is in a adds up to 10 with an odd digit, because all the circles, all the hedgehog balls are odd. So 8 would have to have 2 there, so that's not odd. So this must be then 1 and 9, adding up to 10. This has to be at least 4 or more away from 1, and it has 3 unique digits that are not between 1 and the other digit. So if we had 1 and 8 here, or 1 and 7 here, we are guaranteed there's only 2 digits which are going to be less than that. So this cannot be 7 or 8. It has to be 5 or 6 here. This is 1, which is in a 1 to 2 ratio only with 2. So that's 2. This is 4. This must be 8 here then. 4 is in a 1 to 2 ratio with 2 or 8. And 4 eliminates this possibility of the V here of being 1 and 4. So this has to be a 2-3 pair. And 3 would be the odd digit here. So this is odd, and that's 3. This is 2. That means this can't be 2. That's 8. 3 is in a 1 to 2 ratio only with 6. So that's 6. 2 and 6 are 4 apart. So that works for the wickets. And these digits have to be not between 2 and 6. So it could be 1, 7, 8, or 9. These digits cannot be less than 1, and they can't be between 1 and 5 at minimum. So this has to be 6 through 9. Obviously, 9 can't be here because of 9 in the box. 8 can't be here because of 8 in the column. This can't be 8 either because of 8 in the column. This renban has to have it's either 1 through 5 or 2 through 6. Okay. Um, these two, so adding up to 5 is either 1, 4 or 2, 3. The odd digit would be here. So this would be either 1 or 3, which is with 2 or 4 here. If we had 1 here and 2 here, because 1 is only in a 1 to 2 ratio with 2, 2 and 4 are not going to be 4 apart from each other. So this cannot be 1. This must then be 3, which makes that 2. 3 is in a 1 to 2 ratio with 6. And again, these digits have to be 1, 7, 8, or 9. Now 7 or 9 cannot be in a 1 to 2 ratio with another digit. Actually, 5, 7, and 9 specifically cannot be in a 1 to 2 ratio with another digit. Because if you have 5, 7, or 9, you get 2.5, 3.5, 4.5. If you double 5, 7, 9, you get 10, 14, or 18, none of which are digits. So this has to be 1 or 8. So if this is 1, this would have to be 2. If this is 8, this would have to be 4. This digit, again, has to be 1 or 3 here. If this is 1, it's in a 1 to 2 ratio with 2. Because it can't be 5, 7, or 9 next to the black Croquet dot, or the the ratio hazard. If this is 3, then this has to be 6. So those are the possibilities there. Let's see where to go next. All of these wren bands or mallet, flamingo mallets, must be 1 through 5 in length. So they have to be either 1 through 5, 2 through 6, 3 through 7, 4 through 8, or 5 through 9, all of which require a 5. So keep that in mind. This digit cannot contain a 2 because of the 2 in the box here, 2 in the box, 2 in the column here. So this wren band has to be either 3 through 7, 4 through 8, or 5 through 9. So we're guaranteed we need a 6 on this line. We need a 5, a 6, and a 7. Well, 6 can't be here, or 6 can't be here because of 6's in the row or the box. So 6 has to be one of these two digits. So again, these can be 3 through 9, but these can't be 3 here. 4 cannot be either of these digits. 6 can't be any of these digits. 8 can't be any of these digits. Okay. 8 can't be here because of 8 in the box. Also, so what wren band line is possible here? If this is 5 through 9, the 8 has to be here, so this can never have a 9 there. Well, okay, couldn't have a 9 there anyways. Let's not go that way. Let's figure out where are 3 and 6 in column 1. They cannot be here because of 3 or 6 in the column. Or sorry, 3 or 6 in the box. So they have to be in these 3 cells here. Now the thing is, 3 and 6 both are not 4 apart from each other. So they can't be in this setting here. But they both could be on the wren band line. All we know, though, is 3 and 6 have to be in this set here. 8 has to be one of these 3 digits here because there's no other place for 8. Remaining digits on this wren band have to be 1 through 6 without the 2. Obviously, 1 can't be here because of 1 in the box. This can't be 3 or 6 because of 3 or 6 in the row. So this is guaranteed to be 4, 5. 4 is only 4 away from 8 or 9. So this could be 8 or 9. And 5 is only 4 away from 1 and 9. So this is 1 and 9 here. Well, we have a 1, 7, 8, 9 quadruplet, which eliminates 1, 7, 8, and 9 in the rest of the row. So that leaves the rest of the row as 2 through 6. Well, this can't be 2 or 4 because of 2 or 4 in the column. Where is the 8 and 9 in this upper right-hand box? They cannot be here. They cannot be here because of the black Croquet dot and the hedgehog ball. Can't be here because of the 1, 7, 8, 9 quadruplet here. So this must be an 8, 9 pair here. Okay. So if this is 2, that has to be the lower end, and it must have 6 or 7 here. If this is 6, that has to be the upper end of the lockout line, or the wicket. And so 1 or 2 has to be here. Interesting. Remaining digits of column 6. We have 3, 5, 6, 7, 9. We cannot have 1, 2, 3, 4, 5 because 1, 2, and 4 can't be here. We could have 2, 4, 3, 5, 6. That is... No, we can't. 2 can't be here either. 2 can't be here on this ren band. 2 can't be here. So this must be 3 through 7, 4 through 8, or 5 through 9. Okay. So these digits cannot be 3, can't be 6. This can't be 9 here. There's no 8 possible here. So one thing is, we are guaranteed one of these digits is going to be a 3 or 6. If you have a 3, it must be next to 7, 8, or 9 on the Flamingo mallet handle, because they have to differ in value by 4. So if you have a 3 here, it's with 7, 8, or 9, because those are the only digits which are 4 or more away from 3. And if you have 6 here, it has to be with 1 or 2. Interesting. And we know both of these could be 3 or 6. But we cannot have both of them be 3 or 6 here, so this is guaranteed to be 3 or 6 here. Well, okay, that helps us a lot. Where is the 2 in row 3? Can't be here, because if this is 2, then both of these would have to be 3. Oh, can't be 2 also because 2 in the column. Okay, that's interesting. But this can't be 2 because of 2 in the column, also because of the way that the 3, 6 worked here, but that's neither here nor there. 2 eliminates 2 here, so we are guaranteed a 2 in row 3 in one of these 3 cells. That eliminates 2 as a possibility in the rest of the box. So this can't be 2. It's guaranteed to be 6. That's in a 1 to 2 ratio only with 3. And this has to lock out that amount. So this 3, 6 pair eliminates 3 and 6 in the rest of the box. So this is 2, 4, 5 as a triplet, which eliminates 2, 4, 5 in the rest of the row and box. So this can't be 5, it's 3 or 6. This can't be 2 or 6, and it can't be 7. So that leaves us as 1, which forces this to be a 7 there, because that's the only remaining digit possible. 3 and 6 eliminate 3 and 6 in the rest of row 2. So we know this. We need a 3 and 6 somewhere in column 1. They can't be here, so it can't be here because of 3 or 6 in the row. So this becomes a 3, 6 pair here. Okay. 1 eliminates 1 here. Now, 7, 8, or 9 is not going to be 4 or more away from 6. So they have to be 4 or more away from 3. which makes this a 6. That's 3 in the corner. We celebrate because we're close to solving this. 6 eliminates 6 here, so that's 3. That means this Renband cannot contain a 2 and is 5 in length, so it has to be 3, 4, 5, 6, 7, which means this can't be 9 here. This can't be 8. 6 can't be here because of 6 in the row. Where is 6 on this Renband? It has to be here. And 6 is 4 or more away from only 1 or 2. So this is 1 or 2. Plus we have an 8, 9 pair in row 1. So the remaining digits in row 1 have to be 1, 2, 4, and 5. Well, this can't be 2 because of 2 in the column. We don't have any other information here. We are guaranteed this is a 4 here. Because we have to have a 3, 4, 5, 6, 7 Renband here to form a consecutive set. So this can't be 4, it's 5, which means this can't be 5. That's 4, this can't be 4 or 5, it's 7. 7 eliminates 7 on the rest of the Renband. So this is 5. That eliminates 3, 5, and 6 here. This can't also be 7 because of 7 in the row, so this is 9, which makes this a 7 here. This is 6, this has to be 8 then, and this lockout line has to be a 5 because we have a 6 there. So no 1 or 6 here. Then this Renband line cannot have a 1 on it, and it must have a 2, so therefore it's 2 through 6 here. And the 5 eliminates 5 in the rest of the Renband. 5 is 2... Sorry, it's 4 or more away from only 1 and 9. 5 eliminates 5 here. 5 eliminates 5 there. 8 eliminates 8 here, so this is 9, which makes this 8. This can't be set. Okay, where is the 8 in the central box? Cannot be here because of 8 in the row. Can't be here on the Renband because it's 2 through 6. And this can't be 6 actually because of 6 in the row. So where's a 6 on the Renband? It must be here. 4 eliminates 4 here, so that's 3, which makes this 4 because we can't have repeats on the Renband. 4 eliminates 4 here. 3 eliminates 3 here. And 8 again in the central box cannot be here because of 8 in the row, so 8 has to be here, which leaves this digit as a 3. This digit on the Renband here cannot contain a 3, so it's either 4 through 8 or 5 through 9. That means 1 cannot be here because 1 is not from 4 through 8 or 5 through 9. So this must be 8 here and 1 there. We have to have a 5 here. 8 eliminates 8 in the rest of the column. 7 cannot be on the Renband here, but we need a 7 somewhere. So it has to be here because it's 6 and 8 on the Renband. So this is 7. This can't be 7 or 8 here. The remaining digits here have to be 5 with either 4 or 9. Cannot be 4 because of 4 in the row, so this must be 5 and 9 as a pair. Okay. Remaining digits of column of row 5 are 1 and 2. 1 can't be here because of 1 in the box, so this is 2, which makes this 1. That eliminates 1 here, so it's 9, which eliminates 9 in the rest of the row and box. Remaining digit here has to be 3. That's the only digit remaining. And we can't have a 2 here because of 2 in the column. Remaining digits in row 6 are 2, 4, and 7. 2 and 7 can't be here because of 2 and 7 in the column, so that's 4, which means these can't be 4 anymore. Remaining digit in column 1 is a 5, so that's 5, which eliminates 5 in the rest of the box. So this becomes a 4-7 pair here, which eliminates 4 and 7 in the rest of the box. So this has to be 1, 8 as a pair. It also eliminates 7 on the rest of the line. So to form a Renband, we have 4, 7, and 8. To be consecutive, we need 5 and 6. And 6 can't be here, so this is 5, which makes that 6. 8 eliminates 8 here. 5 eliminates 5 in the rest of the box. And the rest is just normal. Well, we still have that, but everything else is normal Sudoku. Remaining digits in row 7. We have 4, 5, and 7. 4 and 5 cannot be here because of 4, 5 in the box, so this is 7. This must be a 4, 5 pair. This can't be 5 because of 5 in the column, so that's 4, that's 5 there. 4 eliminates 4 here, so that's 2, 5, and 4 there. Remaining digits of row 8. We have 1, 7, and 9. Well, 7 cannot be here or here because of 7 in the column, so 7 has to be there. That leaves this as a 1, 9 pair. We have a 1, 9 pair in column 5 also, which eliminates 1 and 9 in the rest of the column. So this can't be 1, it's 2. That eliminates 2 from being here. We have 1, 4, and 5 as a possibility here. Remaining digits in column 5. We have 3 and 8 remaining. And 8 can't be here because of 8 in the row, or in the box. So this is 3, which makes that 8. Remaining digit in column 7, we have a 2. Remaining digit in column 9, we have a 9. That eliminates 9 here, so that's 1, which makes this 9, which makes this 1. That eliminates 1 here, so that's 8. And this can't be 1 or 8. It's 7 or 9 here. 8 is only in a 1 to 2 ratio with 4 out of 2 or 4. So this must be 4 here, which eliminates 4 in the rest of the box. Also 7 eliminates 7 here, so that's 9, which makes this 7. The remaining digit in this upper left-hand box is only 2 because we can't have 1 or 5 here. So that's 2. Remaining digit in column 8 is a 6. That leaves the remaining digit in row 9 as a 1. That eliminates 1 here, so that's 4. 2 eliminates 2 here, so it's 7 and 2. 9 eliminates 9 here. This is all normal Sudoku. 5 and 9. 5 eliminates 5 here, so it's 1 and 5. 4 eliminates 4 here. 7 and 4. 8 eliminates 8 here, so it's 1 and 8, which leaves this digit as a 9. And that's how you solve it. Yep, pretty normal usage of lockout lines, and all the other Renbands was pretty common. 1 to 2 ratios was also very common usage. Nice little puzzle with the Alice in Wonderland theme. And I hope you enjoyed this episode of Learn How to Sudoku. And I'll see you next time on Frank Puzzles. Take care.